Okay, so second page here we have x plus 8 is greater than negative 3 is an inequality asking us to solve it and then graph our solutions. So I'm going to subtract 8 from both sides. That leaves me with x is greater than negative 11. As a graph, our focus really is on being able to recognize where our number's placed on the number line, and then our type of circle, in this case it'll be an open circle, and it'll be shaded to the right. Okay, so. Alright, number 2, distribute this. Actually, I'm not even going to distribute that. I'm going to divide by negative 3 here from the start. Okay, since we just divided both sides by negative 3, we have to flip our sign. Get 5 is less than or equal to x plus 4. Subtract 4 from both sides. And I'm going to write my inequality with x at the beginning. Make sure that my alligator is still eating the x. X is greater than or equal to 1. So where 0 is, 1 will be on this side. It'll be a closed circle going to the right. Okay. Number 13, I'm going to again try to get the x's the same side and keep them positive. So I have negative 7 is less than 3x minus 19. Add 19 to both sides. 3x is greater than 12. Divide by 3. X is greater than 4. Okay. Open circle at 4. Going to the right. Alright, for 14 is the compound inequality. Remember that with these AND inequalities, really our focus is to be in the middle, and then whatever we do to the middle, just make sure we do to all the sides. So to get x by itself, I'm going to subtract 7, and so that means I need to do that to all the sides. So negative 12 is less than or equal to 3x, which is less than 33. And then divide by 3, dividing everything by 3. So I have negative 4 is less than or equal to x, which is less than 11. Okay, so closed circle at negative 4, open circle at 11, and x is greater than negative 4 and less than 11 works out. All these things in between. Number 15, I am going to distribute in this case because if I didn't, then I would just be moving that fraction and multiplying it on the other side. So I'm going to distribute it here. It'll give me 18 over 3, which simplifies to give me 6x. And this gives me 30 over 3, which simplifies to give me 10. It's greater than or equal to 2x plus 14. Subtract 2x from both sides. And we have 4x minus 10. Actually, I'm just going to do this to save some space, so I'm going to add 10 to both sides. So 4x is greater than 24, greater than or equal to 24. And so now I'm going to divide by 4, and x is greater than or equal to 6. To graph that, number line 0, here's where 6 would be, closed circle, greater than, goes to this direction. Okay, and then finally, this is an OR inequality, so what we're going to do is basically just solving both inequalities. So here's 1, 2x minus 3 over 5 is greater than 1, so I'm going to multiply by 5 on both sides, and that gives me 2x minus 3 is greater than 5. Add 3 to both sides. 2x is greater than 8, and so x is greater than 4. It's one of our parts of our compound inequality. Or the second part, we have to get x by itself, so I'm subtracting 4 from both sides. Negative 3/2 x is greater than 9. Then I have to multiply both sides by negative 2/3. Okay, this way our fraction cancels out. But we multiply by a negative number, so we have to flip the sign. 9 times negative 2 is negative 18, divided by 3 is negative 6. Okay, important here to recognize that we don't just put the numbers where they are in our inequality, we put them where they belong on the number line. So if 0 is here, negative 6 would be on this side of it, 4 would be on this side of it. It is an open circle at 4, going to the right. It is an open circle at negative 6, going to the left. Okay, number 17 asks us to find the x-intercept and y-intercept. Remember that we can do that in standard form by doing the cover-up method. 9x equals 36. Divide by 9, x equals 4. So our x-intercept's at 4, or we could write 4, 0. To do the y, we cover up the x. Don't cover up the sign in front of the y, because that's important. We have negative 2y equals 36. Divide by negative 2. And y equals negative 18. Or 0, negative 18. Number 18. Couple ways that we could do the y-intercept, but to find the x and y-intercept, let's just put it in standard form. So I'm going to add 5x here. I'm going to get x and y on the same side. So I have 5x plus y. I'm going to subtract 15 from both sides. Equals negative 15. And so now I'm going to do the cover-up method again. 5x equals negative 15. That means x will be negative 3. Or negative 3, 0. That's my x-intercept. And to cover up the x and not the sign in front of y, y equals negative 15. No solving to do there. Already done. Boom. Number 19 says the sum of two numbers is 65. Their difference is 25. Find the two numbers. So sum of two numbers is 65. So I'm going to say a plus b equals 65. The difference is 25. Difference just means subtraction. A minus b is 25. Okay, this is already set up for elimination. You can add these two together. 2a, those go away, equals 90. And so that means as I divide both sides by 2, that a will be 45. So one of the numbers is 45. The other number must be 20. Because I plug this in and say 45 plus b equals 65. Subtract 45 from both sides. B is 20. Okay, so there are my two numbers. The number 20 says Ross brought a bouquet of flowers for Valentine's Day. Roses cost $1.25 each and tulips cost 80 cents each. Ross's bouquet cost $14.70. The number of tulips he brought was 3 less than double the number of roses. How many of each flower did Ross buy? So, important to start by saying, what do we want to know? We want to know how many roses he bought and how many tulips he bought. So number of roses, number of tulips. Okay, so the things that we know is that, hey, these roses cost $1.25, these tulips cost 80 cents. Okay, we have one of the equations that's about money, how much he spent. It's one of the totals that we were given. He spends $14.70. We have another one that talks about the number of tulips he bought. Okay, and so its total really is talking about the total tulips. We don't know what that is, but we've already said that that's T. So to come up with the price, we can say, well, each rose costs $1.25. So $1.25 R plus each tulip costs 80 cents, 0.8 T. Okay, we can do the same thing for the, well, not really the same thing for tulips. Tulips is different. It says the number of tulips he bought was 3 less than double the number of roses. 3 less than something, so we're subtracting 3 from something, double the number of roses, 2r. So this is a system that's really set up for substitution, okay, because we have t by itself. So I'm going to solve it that way. 14.7 equals 1.25r plus 0.8, and then I'm going to plug that in here instead of using t, using 2r minus 3. Okay, so 14.7 equals 1.25r plus 1.6r minus 2.4. Okay, so I'm going to add 2.4 to both sides so I can get rid of that. And that gives me 17.1 equals 2.85r. As I add these two like terms together. And 17.1 divided by 2.85 gives me a nice number, yay. So there are 6 roses. So there are 6 roses. Because there are 6 roses, we can find out the number of tulips by plugging it into the second equation. 2 times 6 is 12. 12 minus 3 is 9. Alright.